My name's Pete Haydock. I am one of the folks in charge of the Maker Faire Milwaukee that's happening here in Milwaukee this weekend at the Milwaukee School of Engineering. It's a lot of Milwaukee's actually to say. Um, we are at one level, we were kind of sad. We usually have an education day um, on the Friday before the Maker Faire, but because of COVID, we've decided to go all virtual. And with that, we're presenting the Meet the Makers virtually to our classrooms. So I'm going to stop talking. I'm going to let Kyle introduce himself and share his story. We are super excited to have him. You do a very cool job at a very cool place, my alma mater. So that is I'm happy to share this with you. And Kyle, take it away.
Sure thing. Well, thank you, Peter, and welcome everybody. Truly, it is an honor to get to share my experience that I'm very proud of, but I'm biased. Um, and I need to figure out how I can. There you go. See this. So I do have the blessing of saying I am working my dream job that I always wanted to do as a child. So my name is Kyle Jansson. I'm a mechanical engineer, a machinist, a maker, an inventor, an entrepreneur. And today I want to give you an overview of how I got to where I am and just the career path and lessons learned to get to where I am. I do run the UW-Milwaukee Prototyping Center at the Innovation Accelerator building out in Wauwatosa. And yeah, so as a kid, I played with Legos. I say that's always where it started. I played Nintendo, I played in sandboxes, I played outside, and I always had a knack for wanting to know how things worked. I loved bicycles, so of course in high school I got lucky and got a job at the local bike shop where I could learn how to fix bikes, work with bikes, and get to immerse myself in that world. I went to UW-Madison to become a mechanical engineer, and I had an internship at AT&T on cell phone towers and GE Appliances down in Louisville, Kentucky, which is I learned how it's pronounced, and then at GE Healthcare back in Madison on anesthesia machines. Upon graduation, I went to Eaton Hydraulics in Minneapolis, where I created vane and piston pumps for hydraulics use. Then I went out to the Rockies and worked at an orthopedic research facility with the world's greatest orthopedic surgeons. And I came back to Madison to work as a product development consultant and basically worked on a nitric oxide drug delivery system. And came to Milwaukee to get real close to family, where I worked at Brooks Stevens for a couple years on consumer and automotive products. And as you can see, I'm kind of a jack of all trades, master of none, and that's the way I like it. And at the UWM Prototyping Center, we work on a little bit of everything that I just spoke to. As well as being an entrepreneur, I'm in a medical device startup for a class 1 medical device to secure tubes, lines, and cords to your body to prevent injuries. But like I say, it all started with Legos. When I was a kid, I would save my $2.50 a week of allowance for months at a time, wait till the next pirate ship I wanted went on sale, rush to the store, get it, bring it home. And in reflecting, I noticed I was doing assembly work and I was being an engineer at the time. And I had all this repetition, you can see here in the lower left-hand corner, of how to go about building something. So here's a structured system of directions, but I'm looking at CAD. I'm looking at an assembly drawing over and over and over again. And in the end, I'd have this incredible result. As well as, I'm not an artist. I can't draw, I can't sketch, but I can create what's in my mind using Legos or wood or metal or anything else by creating it with my hands. So I'd have an idea in my head of what I wanted to create, and I could use Legos to put that together and make it and have it in my hands. And that was my favorite thing. I played video games within moderation. The right kind of video games can be very beneficial. The Legend of Zelda was one of my favorites on the original Nintendo, um, but it taught me problem solving, planning, business acumen, efficiency, and quick thinking. You have to have hand-eye coordination. You need to execute what you're thinking of. You need to make a plan and carry that out. So it was problem solving. It is the engineering process. As a bike mechanic, I loved seeing a component that wasn't working or a customer having an issue saying, hey, this doesn't work. And I would have to do an analysis and say, why isn't it working? What's making that sound? Why isn't it shifting? Why is your brake squeaking? I'd have to use a tool and use a trained technique to come up with a method of fixing that. And it was the greatest satisfaction to say to that customer, hey, it's fixed. You can go ride now. Enjoy your summer. And that analysis of discovering a problem, using a technique to fix it, and then watching that positive result occur because of that technique that I had. That was great. I joined an engineering competition at UW-Madison as a senior because I really wanted to improve my hydropack. As an avid cyclist, I loved wearing this hydropack, but when I was out of breath, I couldn't drink from it very well because I just wanted to breathe. So I pressurized this using a Nalgene water bottle, a pressure relief valve, a pressure regulator. So when I bit down on my water valve, water would flow out. I was very lucky to get third place, and it really showed me that I could put my mind to something pretty big, pretty challenging, and come up with a physical, tangible product. And this was a great, fun project for me, and it really pushed me to learn pneumatics a lot better than how I did at the time. My first job out of college was at Eaton Hydraulics. I designed hydraulic components over the span of years. So for example, I went through a design, build, test, brake process. So this valve plate had a lot of pitting, and through a lot of advanced finite element analysis and fluid dynamics and talking to materials experts and tinkering, we were able to go from an initial failed result to a positive one. And eventually you can succeed. I wrote a 44-page technical report documenting the decisions as to why every component in this was the way it was to provide Eaton and its clients with a pump of proper efficiency, noise, performance, and manufacturability. This was our first custom application, and it was used to pick up the back end of this on this palletized loading system. Switching roles, I went to an orthopedic research facility where I would learn from the orthopedic surgeons and scientists what they wanted to test. For example, this is a knee in a robot. We used cadaveric specimens to discover the stability of joints so we could evaluate surgical techniques. And the surgeon said, I need a robot to manipulate this and record data. Well, how do I stick a knee in a robot? First, I would decide what shapes to use to be able to do that. I'd make myself a drawing of the parts I needed to make. I'd go into my shop and machine the part, start with a billet of material and whittle away until I had my finished product. And then I would install it out in the site where we were going to do some testing. So from CAD to implementation, I got to think up what it would be to create the test to give the surgeons and scientists the outcomes they were looking for. And this was a lot of fun. So here I am. I'm going to fast forward to my current job at the UWM Prototyping Center. We have the blessing of, I call them Ferraris of machining centers. We have a 3-axis end mill, a 5-axis end mill, a CNC lathe, a wire EDM, and you can see the machines, but also the parts and shapes that these make. We have an FDM 3D printer, a CNC 3-axis router, a plasma cutter for cutting sheet metal, a surface scanner, surface grinder, welding stations, and a boatload of other manual equipment. And this is all to allow me to make parts with my team to do the behind the scenes work so that I end up giving away the product that does exactly the intention that the user is looking for, our clients are looking for. We've done a variety of projects from tool and dies to scientific instrumentation to bike components to beverage holders to boat panels to jaws to fashion industries. You name it, we've touched a little bit on it. But how do we make those parts? How do we make our inventions? Well, first we have a problem and then we solve it. So here's our CNC router. It makes a lot of dust and I'm lazy and I don't like cleaning. So we wanted to make an improved shroud to capture all that dust. So come up with a number of iterations. This is about version 12 of what you see here, is a telescoping system that can move up and down and actually capture that dust. And in a side-by-side comparison, compared to what we were provided for our original dust skirt, you can see how this actually improves our workflow by cutting faster, making less mess, and cleaner parts. And this helps us with a lot of reasons, but you can just see how a part A is CNC routed, but the benefit that this device has on our throughput. We go from idea to parts. Basically, engineers convert words and ideas into shapes of the right materials. So you want a portable battery-powered oven? Fine, we can do that. This is a way of doing it. Here's the outcome of that. You want to thread holes in concrete? Fine. Let's figure out how to do that. We'll design the tap, design the tool paths to be able to cut that out, walk it to our machine, make that process happen, and then we end up with the final solution and your tapped holes in concrete. And here's that machining process in action. And these are offset passes, so we're not actually cutting anything, but this is how the machine works. All right. And at first you don't succeed. Try again. It's really hard to get something done right the first time. So this is an evolution of a molded part. And you can see how many times it took to get it right. We made small parts with tiny features. Here's our end mill, trying to cut the slot out, to large parts for giant athletes who can't buy conventional gym equipment, to off-road wheelchairs to allow people to get outdoors and a little bit more mobile. We made clean room assemblies to be used in cell or tissue processing or surgical suites. But my big thing is you don't need CNC equipment to be a maker. Anybody with duct tape and cardboard can create what it is you think of. This is a different medium. Again, I'm not an artist, I can't paint, but I can create some. So my kids for Halloween love some costumes. We love the movie Cars. So here's Lightning McQueen. A couple of late nights and a lot of duct tape and cardboard and scissors and tape and crayons and markers. We were able to create their Halloween costumes. This didn't involve anything but a scissors and some passion. And I'm blessed to say I get to follow mine on a regular basis as a mechanical engineer, getting to take ideas and make them. So with that, does anybody have any questions?
So over on the right side of your screen, you can enter in a question through the app called Slido. And yeah, we have our first question here. I'm going to promote it out to live. So that should be good. There we go. So the first question has popped up. What engineering project have you enjoyed most in your career building?
It depends on my mood and memory of that day. That's the hardest question for me. There's a knee brace that I made that I'm really proud of because it helps a lot of people. But I have to say it's a startup that I'm involved in, and I actually have it here. It's a device that's going to hold and secure tubes, lines, and cords to patients. It's an armband from a seemingly simple solution to something that took many years to develop. And you could say, how the heck did that take 5 years to create? And there's a lot of reasons why, but it's a medical device, and the reason I like it the most is it's going to save people's lives and have an impact on society. So I'd have to say this medical device because it's something that we have created from our own blood, sweat, and tears and need, from partnering with a nurse and a manufacturing marketing expert to home grow this and create it from scratch on our own to provide it for society to use.
Very, very cool. What advice do you have for students? This is just my question here.
Yeah.
What kind of advice do you have for, we've got some, let's say some younger students here, some fourth and fifth graders might be interested in being an engineer. What do you tell them to do? What would you kind of say, this is the kind of stuff you want to follow over the next few years?
Yeah. I am blessed to say I followed my passion and I was able to make my day job what I enjoyed doing. And there's too many people who don't love what they do, and I get frustrated and saddened by that. So my advice is, if you love photography, take pictures, get a camera, go to art studios and learn what makes a good photographer and meet people who are passionate about it. Join a photography club. If you like engineering, get a train set, get a car set, get Legos. Just constantly be creating and be tinkering and always be curious, always be hungry. My only advice is follow your passions. I don't I don't intend to tell people they should become mechanical engineers. I only hope to inspire people to follow what they like to do and make a career out of that. And then it doesn't feel like going to work.
Super. Well, we've got another question that just came in. I put it out here. Do you have any coding that's involved? You're a mechanical engineer, so you're really working with metals and woods and plastics and the
Yeah.
polymers and that. But is there coding involved with what you do?
In a lot of the electromechanical devices, absolutely. I am terrible at coding because I'm not educated with it. I took an Arduino class once. I really appreciated it. I loved what that tool could do, but to become competent and become an expert, I knew I wasn't going to be able to put the time and effort into that because you got to kind of pick and choose your hobbies. And so I can dabble with coding, but I'll leave that to experts. And I will gladly partner with somebody who can do coding. And I'm happy for the skill sets that those people have. So you put a mechanical engineer together and a coder together, and you can make something really incredible. But it's a much different skill set than one that I possess, and I appreciate people who can code.
I think we have time for one more question. I'm going to throw it in here,
Yeah.
and then uh, the question I have is, what's on the horizon for you? What's the next project that you're working on that
Oh man.
really is interesting to you?
Um, that's a loaded question. I have my personal life goals. Well, personal life, it's to build a treehouse. Get the permits. I have the design made up to be able to build and fabricate that. I am really excited for to do that with my family. My startup job is to continue to commercialize this device and get it out there. We're about 2 weeks away from starting production. And then we have other versions of this we want to get going. And then my day job is to be able to support our clients. Right now, we're working on a trailer, uh, a medical device for tissue processing, some RC cars, and some really high-end fancy furniture. So it depends who walks in the door on the day job, but I love the diversity, and I want to continue to grow the UWM Prototyping Center to generate more outreach and be able to give people what they're looking for when it comes to the skill sets that we have and share that and continue.
All right, we got two questions kind of came in here. I'd like to throw this out here. What was your favorite Lego set? That's a great question.
Pirates, absolutely pirates. I say that because I had the most pirate collection. I did get, the NASA space shuttle. I still have my little Lego NASA space shuttle on my desk that I stare at all day long. I am just fascinated by what astronauts are and what they can do. But for some reason, I had the most pirate bases and ships. And my favorite thing was after I'd build the pirates ships, you have to break them, tear them down. I would combine two big ones. So I'd have just this massive pirate ship. And it's still assembled today. And my parents have it in their basement for whatever reason. But yeah, pirates, for whatever reason, that fascinated me the most.
You have time for one more?
Absolutely.
All right, we're going to throw one more question at you here. This is kind of a heartfelt question. Was school fun for you? Did you like school?
Yes. Obviously, it was a slog of work. I studied, well, high school, I worked my butt off. Junior high, I worked my butt off. College, I loved the curriculum. I was so hungry that I wanted to read everything. I wanted to do every project. Yes, there were a couple classes I didn't like, but I got to learn heat transfer. I got to learn if I light a candle over here and put a water bottle in it in the way, what is the effect of that water bottle for the heat that my hand would receive? That to me was fascinating to be able to explain that. So I really enjoyed the curriculum. Yes, it was hard. I studied from the moment I woke up Sunday until Friday afternoon. 6 hours of sleep a night. I allotted myself for years. I would take Saturdays off, but I was blessed to be hungry and thirsty going in to want to learn heat transfer, fluid dynamics, manufacturing methods, strength of materials, how forces travel through things. To make my designs better. So I was a sponge.
Super. That is really phenomenal to have that passion, that interest.
Yeah.
And you're right. Students should follow what they're interested in and where they find their passion. I totally agree with that. Kyle, I want to thank you for your time. This is the end of our session. We could go all day. I know we get to see you later on this afternoon at Maker City. Everyone, thank you for joining us. We really appreciate this. We are going to post this on our YouTube channel. We'll do a little bit of editing and we'll send it out to you. I want to thank you for joining us. Hopefully you can join us for our other makers later this morning and this afternoon. Kyle, thank you very much. We really appreciate your time and wish you all the best. Hopefully you all can come to the Maker Faire this weekend as well. Thank you.
All right. Thank you, everyone. Bye-bye.
Bye-bye.